welcome back to another year. We've been running this channel for a year for our new subscribers, new viewers that joined only now. This is now our second year, and this year we'll mainly focus on grade 10 math core, whilst we go and recap some of the other topics that we did discuss on grade 8 and 9 math work in previous year, which is 2024. I hope that all of you had a good festive season, and obviously tomorrow in South Africa the schools are starting for their first term in 2025. I hope that this year would be a very good year for you, and that you would keep on supporting us, as we would like you to also get your friends involved, as well as other people that you might know, to help us grow and support the channel, to ensure that we carry over the knowledge as well as the content that you guys are looking for and that you require to ensure that you are successful in your academic year with regards to math. Like I said, we will be doing a lot of math core work, and with math core I'm talking about grade 10 math core this year, but we will still have our paper discussions, as well as I will go back and do some recaps on some of the topics that we have previously discussed for grade 8 and 9. I'm also looking at completing videos, or doing videos rather, on exercises in specific topics. So please be on the lookout for that. Please ensure that you subscribe, as well as turn on the notification options, so that you are able to view all our videos as soon as they appear on the channel. So without further ado, I'm going to recap the number system. Remember last year our first video was the number system, but I'm going to do it in more detail, hoping that this would be an improvement on our previous video that we did. Remember, we've got a bit of practice now. Last year that first video was a trial run basically. So in this video we're going to go more in depth, and I will explain more in depth and also use examples on how you need to answer these questions. Remember, in grade 8, 9, 10, 11 or 12, doesn't matter which grade you are in, the number system will be asked and assessed thoroughly in term 1, and then again in your June exams, and if they want to, in your final exams. So please make sure that you know what all the different types of numbers are that you do get in your real number system, as well as which categories they fall under. So please stay tuned, and let's get in to the first section of our real number system. So first of all, your real number system consists out of two sections: your rational numbers and then your irrational numbers. So we will start with the rational numbers, and then we'll move on to our irrational numbers, and then finally the bigger part of it, the real and the non-real numbers in the system. Okay, so first of all, rational numbers. Now, rational numbers have a subcategory or a category that runs underneath that, and the sign for rational numbers will be the capital letter Q, but it is written in a certain way. So you're going to draw your normal Q, and then on the left side you are going to put in a little more like a little curve that joins from the top to the bottom. So that is the symbol to represent rational numbers. Now with that, in our rational number system, the first number that we are going to look at is natural numbers. So natural numbers, and natural numbers also have their own symbol, and their symbol would be the following. So to represent a natural number, you'll use the capital letter N, and on the left you'll put in an extra line that goes down. Now, what is a natural number? A natural number starts at 1. So it starts at 1 and it increases. So it starts at 1 and increases in ones. So it increases in multiples of ones. Okay? All the way. So it increases in multiples of ones up to positive infinity. So it starts at positive 1, increases in multiples of 1 all the way to positive infinity. Now with that, if they ask you to write a sequence with natural numbers or the sequence of natural numbers, all you have to do is make a little curved bracket, then you start at 1 and you go 2, 3 and 4. You can stop at 4 unless they tell you to carry on to a specific number, whether it is 7 or 10 or 20 or whatever, you then carry on accordingly. Okay, so this is the first subcategory under rational numbers, which are natural numbers. Then our next category that falls under rational numbers, and I'm just going to keep rational numbers at the top there as a heading. So our next category would be whole numbers. Whole numbers. Now, such as natural numbers start at 1, whole numbers start at 0. But remember, whole numbers also have a symbol. So the symbol that we need to use for whole numbers is the same letter N for natural numbers, but we add a little O. So that is how I normally teach the learners to distinguish between the two. Because natural numbers have a symbol that only has an N, we know that it will start at 1. But whole numbers have an O, which means that it starts at 0. Okay. Now with that, we need to know that whole numbers start, so it starts at 0 and increases in multiples of 1 up to positive infinity. So natural numbers start at 1, increases in multiples of 1 up to positive infinity. Whole numbers start at 0 and increases in multiples of 1 up to positive infinity. If they ask you to write out a number sequence with regards to whole numbers, we start at 0, then we go to 1, 2, 3, 4, and end it there unless they tell you that you need to carry on or stop wherever they want you to stop. Okay, so all of this is what whole numbers consist of. And remember, whole numbers also fall under rational numbers in this case. Okay, so let's carry on to our next heading that also falls under rational numbers. Now, the next heading or next section will be integers. Now, if you know what integers are, you would know that integers consist out of negative values, positive values, as well as it includes 0. Okay. Now, integers also have a symbol, and that symbol is a capital letter Z. Now, you draw the capital letter Z, and then here on the diagonal line, you put in an additional line. And there is your symbol for the capital letter Z. Okay. Or for integers. Sorry about that. Now, integers works as follows. It starts, or let's try to put it this way. So, positive numbers and negative numbers that start at negative infinity and increases in multiples of ones up to positive infinity. So an integer starts at negative infinity and increases in multiples of ones all the way up to positive infinity, because it includes negative values, 0 as well as positive values. So if they ask you to go and write that out, you'll use your curved brackets. Remember to put in your ellipse, which shows that there were numbers before the number that you're going to use now. Then we go -3, -2, -1, 0, 1, 2, 3, and then it carries on, and then I just close it. So these dots show that there were numbers going to the left all the way to negative infinity, and the ones on the right show that there were numbers going all the way to positive infinity in this case. Okay. Then, another thing. So these are your three main sections under rational numbers. But the following also consists and is, how can I put it, sectioned or divided in under rational numbers. And that would be the following: terminating decimals. So terminating decimals. Now a terminating decimal is a decimal that stops. So I'm just going to put it here, it stops. And please, it does not have a symbol like the other ones that I've previously discussed now. So if you're working with terminating decimals, the sign that you'll use would be the Q. And you'll tell me that it's a real number. Okay? Because it exists. You can work with it. You can calculate with it. That's why it's called a real number. But terminating decimals means that it stops. Now to check if you've got a terminating decimal, you have to do the following. So for example, they give you the following. So example, they give you 0,125. If I take the 0,125, you'll see that there are three places, which means the denominator has to have 3 zeros. So we'll take the 125 and we'll put it over 1000. Okay? Then we will go and simplify the fraction. So 125 divides into itself once, and 125 divides into 1000 8 times. Now, if you get a common fraction, you know that it's a terminating decimal, which means it does not carry on and on and on and on like a recurring decimal. Okay? So, another example that we can use here would be the following: 0,75. 2 decimal places, so which means that the denominator has to have 2 zeros. What can go into both of them? 25. So, divide by 25 top, divide by 25 bottom, and you'll get 3 over 4, which means you have formed a common fraction. It does not carry on, it ends at the 5 here, it does not carry on all the way. So as soon as you can form what we call a common fraction with the decimal, you know that it is a terminating decimal, which means it stops, it does not carry on forever. So this also falls under real numbers as well as rational numbers, which I will get to later. I will show you how to categorize them. Okay. Then the next topic that also does not have a symbol, that also falls under rational numbers, would be recurring decimals. So recurring decimals. Now recurring decimals, they do not stop. They do not stop, they carry on. So the terminating decimals stop, recurring decimals do not stop. They carry on forever if you allow them to. Okay, so example on this would be the following. 0,1 recurring, the dot shows that it recurs, so which means it carries on all the way, and the dots will show you that it carries on. Okay, another example that I like to use is one like I'm going to show you now. 0,52, both of them have dots, which means that both the 5 as well as the 2 recurs. So 0,52, 52, 52, 52, and then it carries on and on and on and on. Okay, so if you have 3 decimals and each one of them have a dot, it means that each of them is repeated, it recurs, it carries on. Okay, then another topic that falls under rational numbers that you can include would be fractions, and these are fractions. Okay, these are fractions where the numerator and denominator, the numerator and denominator is not equal to 0. Okay, so for example, any fraction such as a common fraction like this or like this, it is not allowed to be something like this, because this means undefined. An undefined value is not a real number but a non-real number, like I will explain just now. Okay, or simply something like this. Okay, so these are normal fractions where the denominator or the numerator is not equal to 0. Okay, then our final category that falls under the rational numbers, and that would be mixed numbers. Mixed numbers. For those that do not know what's a mixed number, you would have also probably been taught that it's called a mixed fraction. So, for example, 2.5, there's a mixed fraction. It's got a whole number as well as a common fraction associated with it. If I go and I change this to an improper fraction, I will get 5/2. And the reason why the fraction is a rational number is because both the numerator, which is 5, and the denominator, which is 2, are integers. Okay, so both these things are integers. If you look at the next one, for instance, 3 and 2/3, if I go change them, you get 11/3. The 11 and the 3 are both integers, and that is why mixed numbers are also categorized under rational numbers in this case. Okay, so those are your rational numbers. I will summarize them for you right at the end, before I show you how to write them when we work with the exercise. Okay, now we're going to move on to irrational numbers. Irrational numbers. Remember, all of them fall under the real number system. Okay, so irrational numbers. So irrational numbers also have a symbol. The symbol for irrational numbers is similar to rational numbers. Remember, rational numbers have the letter Q. Now, irrational numbers also have the letter Q with the second curve, but the thing that we add there is a 1 at the top, and that is the symbol for irrational numbers. Now, irrational numbers consist of the following. First one would be the symbol pi. And the reason why I say the symbol pi, because irrational numbers focuses on the following, and that would be non-recurring decimals, and non-terminating. Decimals. So it focuses on non-recurring decimals, decimals that do not repeat the same values the whole time and carries on forever and ever and ever. As well as it also focuses on non-terminating decimals, meaning decimals that do not have the same number that is repeated, but it never stops. It carries on, even though it shows different numbers for each decimal place value that it continues with. Okay, then irrational numbers also categorizes non-perfect squares. So non-perfect squares. These are values that are square rooted but does not give you a whole number for an answer, if I can put it that way. So perfect squares would be values, here's my calculator, would be values so that I can show you, such as the value of 4. If you square root 4, you should get 2. That gives you a whole number. But if I go and square root 2, for instance, it's going to give me a decimal value. So non-perfect squares are included in irrational numbers. Perfect squares are included in rational numbers because the value that it gives as an answer can be classified as a whole number, an integer, as well as a natural number. Okay, then the final topic that is categorized under irrational numbers would be the following. That's supposed to be a 3. And that would be non-perfect cubes. So non-perfect cubes are the same as perfect squares. The only thing is that it has a 3. So 3 times a certain number would give you the value that's inside there. Now, non-perfect cubes are similar to non-perfect squares because when I put this into my calculator, let me rather show you. When I put this into my calculator, it will give me a decimal answer, which means it's not a perfect cube, which means that anything else, such as if I would use the cube root of 27, which would give me 3, if it gives me a whole number, it would be classified under rational numbers, which would be also called a perfect cube. Why under rational numbers? Because the answer can be classified or categorized under whole numbers, natural numbers, or integers in this case. Okay, so your real number system consists out of 2 things. So I'm going to erase this. I'm going to draw a diagram for you so that you can understand, and then I'm going to continue to non-real numbers. Okay, so your real number system. So real numbers are categorized as follows. Remember, the first thing that I discussed with you were rational numbers. And it has a symbol of capital Q. Now, underneath rational numbers, we get the following. It would be natural numbers, which has a capital N for sign. It also includes whole numbers, which has a capital N with an O as a symbol. It also includes integers, and that has a capital Z as a symbol. Then, furthermore, underneath that, we include the following, which would be terminating decimals, remember that it does not have a sign or symbol. We also then include recurring decimals, it also includes then fractions where the denominator and numerator is not equal to 0, as well as mixed numbers. So there is your whole rational number category. So all of this falls under rational numbers, but they are called real numbers because they exist. So these numbers exist because you can calculate with them. Okay, now the other part that falls under real numbers. Oh my goodness, let me just get another marker. The other part that falls under real numbers would be irrational numbers. So irrational numbers have the same symbol as rational numbers, but it has a 1 at the top. And rational numbers include, so everything that is categorized under rational numbers are the following: non-recurring and non-terminating decimals. Okay? The other thing that's also categorized under irrational numbers would be non-perfect squares. So non-perfect squares. Then the last thing that is categorized under irrational numbers would be non-perfect cubes. And there you have all your real numbers categorized as we go now. Okay. The thing that I'm going to explain to you now would be non-real numbers. So remember, real numbers exist. We can calculate with them, work with them. You need to know this. Now, we are going to quickly have a look at non-real numbers. So, non-real numbers. Now, non-real numbers. Non-real numbers are imaginary numbers. So they're imaginary numbers. They do not exist. They do not exist. Please. You cannot work with them, you cannot calculate with them. They will always give you a math error when you put it into your calculator. Okay, so non-real numbers is any number. So any number that is undefined or gives math error as, oh my goodness, as an answer. So it's any number that is undefined or gives math error as an answer. Now, these numbers are as follows. Any number that is divided by 0 is equal to undefined. Okay? Any value that is square rooted, that is negative, will be non-real. Because it does not exist. Quickly have a look here on your calculator. If I put into my calculator 2 divided by 0, it gives me math error. But what you need to write in your test and in your activities is undefined. That is the term that we utilize. The same with the following over here. If we square root, let's say negative 2 for instance, your calculator will give you math error. The correct terminology to use is non-real, because it's an imaginary number, it does not exist. That's why the calculator tells you math error. That is how we write these values and the answers for them. Okay. Now one more thing that I would like to touch on. Okay. Remember I said to you that pi is irrational. So pi is irrational, which means there's the symbol, it's irrational. But pi has different forms. So if you do not use the symbol, pi is equal to either 22 over 7, or pi is also equal to 3,145, and then it carries on. Any time that it is written as a numerical value, then it becomes rational, because it has a physical value that you can use to calculate a sum, a question, whatever is given to you. But as soon as you use the symbol pi, it becomes an irrational number. Okay? Because the reason for that is that pi, if you type it into your calculator over here, shift pi, if you type it into your calculator, it gives you all these decimals. Okay? Which means it is non-terminating, it carries on. Okay? With that, as soon as I use the decimals or the improper fraction, it becomes a rational number, because I can limit it, and I'm working with an actual value that I use, or that I can limit. I can use the first 3 decimals, or I can carry on to the first 5 decimals that I want to utilize. Okay? But as soon as I work with the symbol, I cannot restrict the actual value of the symbol to a number of decimal places that I want to work with. Okay? That is why. Now with that, I've explained what real numbers are, what non-real numbers are, as well as what rational and irrational numbers are. Okay. Now with that, if they give you an exercise, and we love to do this in your exams, in your cycle tests, it doesn't matter what you are writing, your first 2 terms, you will get something like this. So we'll either give you a table, or we'll give you values and then tell you to tell us what type of numbers these are according to the real number system. Okay, so I'm just going to write a couple of numbers down and then show you how to answer them. Sometimes we'll give you a table where we give you the symbols and you have to tick which symbols are applicable to the number. Or we can give it to you like this, and I can ask you the following. So you need to tell me everything about the following numbers. So negative 1,5 is the number that I give you. Now, you know that you can work with negative 1,5, okay? Which means negative 1,5 becomes an integer, and it is a terminating decimal. So the first thing is that it's a rational. It's a rational number. Okay? And rational numbers, symbols, would be Q. With that, rational numbers fall under real numbers. There we go. That is where that number belongs. The next one, let's look at 0, for instance. Now 0 is a real number first of all, because it falls under real numbers. We can use it, we can calculate with it, etc., etc. Also, with that, 0 falls under rational numbers. Okay? Then, with that, under rational numbers, 0 belongs to whole numbers as well. So, it is classified under 3 sections. And we narrow it down as we go. So, next one, 2 over 3, which is a fraction, can be classified as a real number because we can calculate with it. It can also be classified as a rational number. And that's it. Now, if we give you the square root of 3, for instance. Now, the square root of 3 is a real number. Yes, because we can calculate with it. If you go and look for an answer, you're going to get a decimal value, which you can work with. Then, with that, it is not a rational number. Okay? It is not a rational number because it's not a perfect square, which means it falls under irrational numbers. And there you've categorized it. Then, if we move on, we look at the symbol pi, for instance. The symbol pi is a real number because you can use it to calculate. Then, with that, it is also an irrational number. Remember, I told you, only if we give you the numerical values of pi, it becomes a rational number. So, at this stage, if you work with the symbol, it is irrational. Then, if you look at something like this, -6, the square root of -6, immediately that is a non-real number. And non-real numbers are not divided into subcategories. They only have one category, and that's the main one, which is non-real numbers. So guys, this is how we will ask you to answer the questions. And as we move on with all of this, I will do activities or exercises where we use the tables with the symbols. I give you the numbers on the left going down, symbols moving across at the top, and you have to tick which category they fit in. It's exactly the same as this. You are just not going to write it out, you are going to tick where it is applicable and where they do fit in. Well, thank you for watching the first video of the year with us. Thank you for your support. I do hope that 2025 is going to be a prosperous year. Sorry for the mispronunciation. Prosperous year for you, and that we will work together to enhance your knowledge as well as your skill in math. I've got big things planned for the channel where we will look at paper discussions. We will work through tests, exam papers, exercises for both grade 8, 9 as well as 10 math core, and we'll see how the time allows us to carry on with the channel, and then we might also introduce grade 10 math literacy. If not this year, then we will include that next year. I do hope that all of this helps you. Have a good evening further. Until next time. Goodbye.